I work for the DZ Bank in Frankfurt, Germany. If you don't know it, it's the central bank of the cooperative banks in Germany. And I work there in the Department of Information Management. But yeah, nothing of this talk has actually anything to do with my employer. This is more a hobby module and not something we use at work. Well, yeah, at work, and I'm sure you also have this situation, I write some applications in Perl, and once these applications actually start solving problems, there comes the issue of who gets access to these applications. The first step is usually that simply everybody who knows about this application also gets access to that application, but sooner or later there always comes the problem of limiting access. Not everybody is supposed to be creating new users or deleting some data or whatever. So then I have to introduce passwords for users, or maybe SSL certificates, or other methods that can restrict access or tell me who the person is that is actually using my application currently. When doing authentication in an ideal world, there are usually 3 things that make up a good authentication. That is something you know, like a password. Then, in addition to that, something you have, like the key to a door or something else that is not easily duplicated. And also something you are, like a fingerprint or some DNA sample or maybe some iris scan or something like that. Two-factor authentication tries to use 2 of these 3 factors for authentication. The standard way on the internet is usually the 1-factor authentication simply by using a password, but 2-factor authentication would then be something using something you know, a password, and then maybe something you have, or maybe something you are, but in the example I will present, this is about something you have. Why do people want to move to 2-factor authentication? It's usually because a single password is just not enough. You could, for example, have a keyboard sniffer installed somewhere, maybe simply on the network because you are not using HTTPS, or maybe a real keyboard sniffer that just plugs into your keyboard as a USB adapter or something else. Or maybe it is simply because passwords get shared among colleagues. They ask you, just tell me the password for this and this machine, or something like that. And such practices usually then lead to a monthly password change, or even shorter periods, like this password is only valid for a week, then you need to change it. And whenever you have such regimes of needing to change your passwords every time, this leads to weak passwords, and people simply use the year and the month in the password and number them like this. So changing your password frequently does not really help the problem. So people have the idea of, for example, using one-time pads for passwords. That is, every time you log in, you look up in a code book the next valid password, enter it, and then strike it off the list. But having such a code book with passwords is quite cumbersome because you need to distribute these passwords and everything. So it would be more convenient if this password could automatically change both on the server and for the user, but still the server and the user would know when to use the new password and which password to use. Now, there are already some password approaches with having two factors for passwords or for authentication in use. For example, in online banking, at least in Germany, we have well, some older mechanisms rely on a real one-time pad. Every year or something, your bank sends you a big sheet of paper with lots of numbers on it. And every time you do a money transfer, they ask you, please enter the code for number 42. And then you pull out that big sheet of paper, strike out the relevant number, type it into your online banking, and yeah, then they execute the money transaction. The two factors are, one, the password that you logged in with your, into your banking account, and that number that you can only know if you have that sheet of paper. So the bank then believes that you are yourself because you have those two things, the password that you know and the sheet of paper that was sent to your postal address, which is fairly secure. But distributing sheets of paper is not quick, it's a bit cumbersome, and well, if you are traveling somewhere, maybe you didn't bring the sheet of paper with you, but you want to send somebody money, like some prince in Nigeria or somebody else. So there is another secondary channel that has become fashionable whenever you want to do a monetary transaction. Instead of entering the number from a sheet of paper, the bank sends an SMS to your mobile phone, and in that SMS is just a code, just like with the sheet of paper, but it's sent by a text message to your mobile phone, and you then enter that code in addition to your password. And again, the belief is if you know your password and you have access to that mobile phone number, then it's most likely that you are actually the person who has the right to work on this money account and send money everywhere. Now, there are also many other schemes like this that do not rely on SMS. For example, the RSA tokens. They are little USB tokens that have a small number display that changes every minute or every 5 minutes. And you use that for login, or the YubiKey USB token. Or if you are playing World of Warcraft, there's also the Battle.net Authenticator, which does the same thing. And not to be left behind, Google also implemented two-factor authentication. And to make it really easy for others to also implement two-factor authentication, they wrote the GoogleAuthenticator application, an application for Android and iPhone devices that turns your mobile phone or your iPod or whatever into such a number generator that you can then use to display, to generate a login code. Like I said, it's available for iPhone as well. And it stems from the initiative for open authentication, because Google is trying to make account stealing harder, because lost accounts mean that Google has to do customer service, and customer service is quite expensive for Google, and they are bad at it. I don't know which one is the more important thing, but yeah, if they can prevent Gmail accounts from being stolen, that's much better than having friendly, nice people helping people to recover their Gmail accounts. So they founded this initiative for open authentication, and they came up with the TOTP algorithm as documented in RFC 6238. And yes, this algorithm is what the Google Authenticator application implements. One important thing is there is no network connection required. This works anywhere. You don't need to send or receive an SMS. You don't need to contact Google at all. If you are logging into an application, this is simply a calculation performed on the server, and the same calculation is performed on the client, your Android phone or your iPhone, or whatever other device. It doesn't need to be a phone device. And yeah, the only thing that's transferred is the number from the client to the server. You can find this app on the Google Play Store, and there is also some compatible application written by dynalogin.org. It's basically the same application. It looks a bit nicer and is not by Google. I don't know if they have any actual advantage over using the Google application. Now let's take a short look at how the TOTP algorithm is supposed to work. It relies heavily on UTC, the Universal Coordinated Time or Universal Time Code. I never know which one is which, but I think there's a talk about time zones and nastiness later. And the idea is that the algorithm takes a shared secret, a secret that your mobile phone knows and that the server knows, takes the current time, hashes them together in a way that is really not reversible, and gives you a 6-digit code that you can then use to authenticate to the server. And yeah, this looks like this in the application. It shows you some account, the test2 account, and then in large friendly letters the current code you need to enter. And a minute later, that code has already changed, and hopefully nobody can predict it from sniffing your network traffic or something like that. But yeah, the shared secret is already the major weakness of this approach, because everybody who knows this secret can also calculate this code here. So this secret needs to be protected very much like a clear text password needs to be protected. Now, how does the workflow work? What does a user who has signed up to your website or wants to work with you, what do they need to do after they have installed the Google Authenticator application? Well, the users can simply log on with their normal password. Then they set up the two-factor authentication with their device. And yeah, then later they can simply log in with both their password and their mobile phone. They cannot log in anymore only with their password or only with their mobile phone, but they need both the password and the knowledge of what the mobile phone shows on its screen. And yeah, when doing the setup, the user sees basically this screen. And yeah, the setup needs to be easy, because if it's not easy, the users won't use it. And the original idea is you enter the shared secret manually. That means typing it in on a phone screen, which is a very bad idea because it's a long base 32 string, RFC 354H compliant, and they look like this, and no user is going to enter this correctly, and they will be calling you, my login does not work, I've lost my password, or whatever, or your application does not work, even worse, just because they didn't type in this long string correctly. So yeah, manual entry is simply out of the question. But conveniently, we can simply scan a barcode in this application. And yeah, CPAN has a module for generating barcodes. So the easy way is to have the user simply photograph the screen when configuring two-factor setup. And yeah, all the user needs to do is hold their phone in front of the screen, and the secret gets shared between the computer screen and the mobile phone. And now I'm going to try the live demo. I've written a tiny dancer application that yeah, basically is nothing more but a login screen with yeah, the capability of setting up two-factor authentication. And it also lives in the CPAN module, so if you download it, you also get the demo application right with it. Now, first we try to log in, and we will use the user test 2, and the password has 5 letters and ends with 2. You can guess the other 4. And we don't have two-factor authentication set up yet. So now if we log in, yeah, we see a big loud, big friendly letters that we are now logged in as user test 2. And the only 2 options that are available to us are either to log out again, well, not really useful, or to configure two-factor authentication. We'll do that now. And yeah, the application tells us that for this user, there is no two-factor authentication set up yet. And I will now set it up. And yeah, first, below here, the application tells me that long string that the user could enter manually into their phone, but I am lazy, so I will try to take a picture now. And yeah, it has now taken a picture. Can I give you that thing? Just hold it, please. And yeah, we will log out now for a moment. And now some time passes. And we will try to log in. First, I try again with test 2 and test 2. But now, simply using the sniffed password does not work. The user cannot log in anymore. And if we look at the log, it also says we entered the wrong OTP code for this application. So now, I'm trying again with the correct password, and please
353
353
728 729
729. And And yay! Actually, it works. It was very little setup, and yeah. Now we have two things that need to work together to get access to the application. We need to know a password, and we need to have some device in our hand that tells us the correct number. Now, I know I've surprised you, but let's assume that someone of you took a quick picture of that barcode while it was on screen. Then you could too generate the same code, because everybody who has seen that QR code can in theory also generate these codes. And for that, I want to show how easy it is to replace the shared secret. I can simply regenerate it. Currently, our code starts with OAY, and I will now regenerate it. And we get a different code. It now starts with NV3. And yeah, swapping or switching to that new code is just as simple. I just need to take a second picture. And yeah, now I have the new code. And yeah, that's it. Changing the password is very easy. Simply take another picture. So yeah, that's for the live demo. Now let's take a look at how the module, or what the module can do for you when you are moving your application to two-factor authentication. Well, first you need to create the Google Authenticator object for your user. And yeah, you need to pass it this shared secret. Here I've chosen an exemplary, really bad value. Test@example.com is not a really good secret. You should use a long random string for each user, because yeah, this is supposed to be secret and nobody or no human ever sees or uses this string. And yeah, the module has a function to return the registration key. This is the long base32 string that you saw. And it can tell you the current code that will need it with the TOTP function. And it also has the verify function, which simply tells you is this user input the valid code that we need, yes or no. This is basically your shorthand login handler. You give it the value and it says, yes, it's okay, or no, it's not okay. And all of this also lives in a small Perl application, just to get you started. So you don't even need a web server for doing two-factor authentication. You also can completely work from the console, or maybe even set up the same thing as an SSH handler to secure your SSH login also by one-time password if you want to. And yeah, I've pre-configured this account from the test thing on the tablet too. And surprising, it does not show the same number because both devices are looking at what they think is the current time. And my tablet is a few seconds off from the notebook. So they show a different code. The notebook shows 701 and the tablet currently shows 655 as the current login code. So as soon as one device thinks it's a bit later, you will have to compensate for that in your code. For example, an easy thing is to simply allow not only the code for the current minute, but also for the code for the last minute and for the next minute, so that your user can have a device that is up to 1 minute early or late. This comes at a price, because it also opens a window of 3 minutes where an attacker can sniff the code and then use it on your website. You have to consider whether it's easier to synchronize all the clocks on your devices or to allow such a 3-minute attack window. I see your question.
You can simply disannul the reuse of the same code.
Yes, that's also a good idea. Once somebody has logged in with a valid code, you put that code onto a blacklist for the next 10 minutes, because after that it's invalid in any case, and you only allow 1 login per minute using the Authenticator, so then nobody can sniff and reuse that number unless they are faster than the person doing the legitimate login.
How about running things off SSL as well?
Yes, I'm not discussing whether to use HTTP or HTTPS, but as you are transferring, in addition to this code, a password, you should use HTTPS in any case, because transmitting a password in clear text, is not really wise unless you don't have that much data to really protect in any case. So yes, basically HTTPS should be enabled. Another question.
Can mobile device send some information to server that this key already is used, so that no other device could scan this QR code and set this configuration?
If I've understood you correctly, you want
This is like this Battle.net Authenticator used for World of Warcraft.
Yes.
If you have connect one device, you cannot use any other.
No, this algorithm is simply based on time. So you can have any number of devices and they will all show the same code at the same time. There is another version of this algorithm that works like a counter, and every time you use it, it counts by 1 and generates a new code. And with that other version, you can only use 1 device to generate the next number, because they all keep track locally of what the current number is. But this version you can use on as many devices as you want. And you increase the security hole by every device you copy the secret onto. So, yeah. Now, how does the API map to what the user sees? Well, we have the secret. No user and no administrator ideally should ever see the secret. Then we have the name for the account. This is whatever the user likes it to be, like my home banking, or I don't know, code for the atomic bomb or whatever. And in yellow is the key. This is what is returned by the registration key function. And then on the main page of that application, we have that large friendly number, which is the current code for this account. And that large friendly number is also what the value that the TOTP function returns. And whenever these two are equal, you have a legitimate user that is allowed to log in. The registration URL function generates this OTP auth URL, and these URLs are what make Google Authenticator work together with the camera to recognize that this is a picture for storing. And yeah, it generates a URL of this type, OTP auth, then TOTP for the time-based OTP algorithm, then the name that the user will see on screen, and as a parameter, the shared secret. And yeah, this is very important. This shared secret must really be protected. This also means when you are displaying this shared secret as a QR code, you should not cache that image on disk or transfer it unencrypted. You should really use HTTPS and not use any caching HTTP servers in between you and the users. Yeah, that we already are in the middle of the security implications. Yeah, basically that shared secret is very much like a plain text password. If you see it or if you get access to any of the devices, you have that the shared secret and you can impersonate the person using the login. It's not possible to hash the shared secret like you would do with passwords. And unfortunately, RFC 6238 has no advice on how to handle those shared secrets, like where to basically store them. So yeah, you have to treat them like plain text passwords. But one upside is that changing the secret is very easy. The user just needs to take another picture of the screen and they have been changed to the new one-time password. But you really should always use a secondary factor like a normal password that you can hash or maybe a biometric reading, because, well, copying this is far too easy and it's really hard to make this data secure for a longer time. And yeah, if you are using two-factor authentication only for parts of your application, maybe viewing things is just protected by password, but changing things is protected in addition by this code, then you should put a time limit on that escalated privilege. So yeah, no session stealing is easily possible. But at least two-factor authentication, yeah, it makes your application potentially a bit more secure, because password changing is of medium hassle for the users, while code changing of the TOTP code is really easy. And if you have a data leak, like maybe your table with user accounts gets spread into the public, then finding the original password is very hard, provided you use bcrypt2 or bcrypt to hash the passwords. But yeah, recovering the secrets is trivial, because they are just a column in the database and everybody who sees that column can also has the secret in their hand, but the combination makes it still hard to actually access a user account on your live system. Now, there have been quite, or not quite, but some companies already use two-factor authentication, but still users lose their passwords or get their accounts hacked. For example, Google, like 6 months ago, had some Google users lost their accounts even though they used two-factor authentication, but it was that the hackers simply did not attack the parts protected by two-factor authentication, but attack the protocols that did not use two-factor authentication. For Gmail, that would be IMAP or POP3. Anything that can go automatically, yeah, is easy to attack like that. And also Evernote seems to have used two-factor authentication, but I could not find any reference to it. But yeah, if you have something like direct links to files or direct links to other data that don't require a login, it's easy to circumvent two-factor authentication that way as well, at least to see that specific data. There is also Auth.com, a hipster application that does the same thing as Google Authenticator does, except they also offer you to synchronize your secret with all your other devices and their server. But yeah, that's not how a secret works. That secret should never leave your mobile phone or whatever other machine. And yeah, sharing that secret, yeah, it just doesn't make sense. So if you are moving to two-factor authentication, you need to change all access methods. Don't leave any doors open like some emergency things. But then you really need to think about password resets or lost mobile phones. And my idea is to have the user print out 3 master reset codes, very long codes that they can enter to do a master reset on their account. And yeah, hopefully they have that paper in hand when they lose their mobile phone. Google Authenticator uses basically 3 modules. Auth, which implements the algorithm for calculating the current key. Imager QR code, which displays the nice QR code. And Dancer for the demo web application. You can find the application itself on the Google Play Store. It's also available for the iPhone. And all my code is on CPAN as usual. Thank you. Are there any questions? I don't know how much time I have left.
1 minute.
1 minute, so maybe 1 or 2 questions. Yes?
The application for the Android or iPhone is only one. Can it be modified to have, or sorry, I as a user, can I install it more than once on my
Yes,
side?
that application can display many keys for how many accounts you want.
Okay.
And it's also open source, so you can write or rebrand that application for your company as the whatever booking authenticator or whatever.
Thanks.
Yeah. Another question.
Well, how about, have you considered encrypting your secrets on the server?
Yes, you can encrypt the secret on the server, but you need to store the decryption key at least in memory.
Yes.
Yes, that is a sane advice, to store the secrets encrypted on disk and only decrypt them in memory.
That is, on average, not done.
Yes, it's not done, but it would be a very good way, because if you lose your backup or whatever, then the data is at least not in plain text.
Right, I have a web app, and if I start it up with Answer app, it makes me enter my code, and then it encrypts it.
Yes.
It knows how to decrypt and encrypt.
Yes, entering the code at server startup or the password for the secret
It sits
key.
on the heap, but that's the best I can do.
Yes. Okay, any more questions after this talk? Thank you again.